Okay, I'm going to work through the review for the test tomorrow, which is on Thursday, February 5th. Let me turn off the sound. There we go. So we don't have a echo. Okay, so number 1, find C. Now there's 2 ways here that you could find C. You could do Pythagorean theorem, but it will take a little bit longer. So because this is a 45, 45, 90 triangle, I'm going to use our formula, hypotenuse equals leg times square root 2. So then fill in what you know. Well, we're trying to find the hypotenuse, that's C, and we were given a leg. So hypotenuse equals 7 square root 2. I can't simplify that at all. So our answer is B. Number 2, find X. Again, you could use Pythagorean theorem, but we know that we have the special right triangle, 30, 60, 90. So we have several equations here. We have 2. We have hypotenuse equals short times 2, and we have long equals short times square root 3. So then you have to look at what information you're given. Well, this is the long leg, the short leg, and the hypotenuse. So I want to find the long, but in order to use this equation here, I have to know what the short leg is. So let's go ahead and fill in this one. The hypotenuse is 50 equals short times 2. If I divide by 2, I find out the short leg is 25. So now I can plug that into this equation. So long equals 25 square root 3, and I can't simplify that at all, so my answer is C. Number 3, you have to first ask yourself which kind of triangle this is. Is it a 45, 45, 90, or is it a 30, 60, 90? So in order to tell, if you're given a square, you can see these congruent marks. That means these sides are the same, which means it's a 45, 45, 90. Okay, so we're given the hypotenuse and we want to find a leg. So we're going to use our equation, which remember, you're going to be given these. So hypotenuse equals leg times square root 2. And they gave us 30 is the hypotenuse. So in order to solve for the leg, I'm going to divide by square root 2. Now we're not going to leave our answer like that. We're going to get rid of that radical on the bottom. And in order to do that, we're going to multiply that same radical on top and bottom. So we get 30 square root 2 over, when you multiply square root 2 times square root 2, the square roots go away and you just get 2. So that equals 15 square root 2, which is the leg. Number 4, find X. So again, ask yourself, well, what kind of triangle is this? Is this a 45, 45, 90, or is this a 30, 60, 90? So because these two sides are the same, and I'm looking at a square, then I know that it's this one, not a 30, 60, 90. So as soon as you know it's this one, write your equation that we're going to use. So we're trying to find the hypotenuse here, and they gave us the leg. So hypotenuse equals leg, which is 1.2 times the square root of 2. And we can simplify that, so we'll just leave it like that, 1.2 times the square root of 2. Number 5, find X and Y. So now we have a 30, 60, 90 triangle. So let's label our sides here. This is the short, this is the hypotenuse, and this is the long. So hypotenuse equals short times 2, and the long equals short times square root 3. So we have the 2 equations, and I would say just write them and then fill in what you know. The only piece of information we know is the long leg. So we'll put 15 here equals short times square root 3. In order to solve for the short leg, I need to divide by the square root of 3. So now we have, come up here, 15 over square root 3. Again, don't leave it like that, so we need to get rid of that radical. Multiply by square root 3 over square root 3. So on the top we have 15 square root 3 over, when you multiply these radicals, you just get 3. You can reduce this 15 and 3, So we find out the short leg is 5 square root 3. And the short leg was x, so then in the x blank, we'll put 5 square root 3. Then y is the hypotenuse. So in order to find the hypotenuse, we did short times 2. Well, we just found the short leg was 5 square root 3. When you're multiplying, you can multiply these numbers on the outside, so that would give us 10, and the square root 3 just has to stay. And that is y. Number 6. In parallelogram ABCD, AD is 14, and the measure of angle D is 60. Find AF. So let's put an X here. Now I'm going to redraw that triangle so we can look at what we've got. We've got a 90-degree angle here, 60 here. They told us AD is 14, and this is X. So we're given the hypotenuse, we want to find the long leg, and then this would be the short leg. Now, in order to find the long leg, we have to know what the short leg is. So let's set up our two equations. So hypotenuse equals short times 2. So if I put in hypotenuse is 14, I would divide by 2, and I find out the short leg is 7. Now, even though they don't ask for that, that's how I have to get to solving for the long leg. So now in order to get the long leg, I plug in the short leg, which we just found was 7, and I can't simplify that. So AF is 7 square root of 3. Okay, number 7, find X and Y. So we have a 30, 60, 90 triangle, and we want to find the short leg and the long leg. And these, if this is 90 and these are both 60, this has to also be 30. So these are both the same triangle. So if this is 39, then this is 39. So there's our hypotenuse. So let's set up our two equations. Hypotenuse equals short times 2, and the long leg equals short times square root 3. So the hypotenuse they told us was 39. So if we divide by 2, 39 divided by 2 is 19.5. So the short leg is 19.5, which is X. So if I look here, well, so far it looks like the only one can be this one, where X is 19.5. So let's check that then. The long leg, I would plug 19.5 into here. 19.5 square root 3. I can't simplify that, and that is Y, which is right here. So our answer would be C. Number 8, how high is the end of a 70-foot ramp when it is tipped to an angle of 45 degrees? So we're finding this side right here, which is just the leg of a 45, 45, 90. So our equation for 45, 45, 90 is hypotenuse equals leg times square root 2. Well, they gave us the hypotenuse was 70. So 70 equals leg times square root 2. Divide by square root 2. Again, don't leave that radical in the bottom. So multiply top and bottom by square root 2. When you multiply these, the radical goes away, you get 2. And you can reduce this 70 over 2 to be 35 square root 2. Number 9, find X. So we have this whole thing is an equilateral triangle. So just like on the front page when we saw a square is going to be your 45, 45, 90. And when you see an equilateral triangle, you're going to use 30, 60, 90. This is your 90. This is 60 because equilateral triangles have a 60-degree angle, which means this is 30. Okay, so if I just redraw that half of a triangle, I have the hypotenuse is 24, the long leg is X, and the short leg, if the whole thing is 24, this is splitting it in half, so then this is 12. So if I want to find the long leg, long equals short times square root 3. So long equals 12 times square root 3, and I can't simplify that at all. So that is what x equals. Number 10, find the perimeter of a square if the length of its diagonal is 12 inches. Okay, so we're going to find the whole thing. We're going to add all the sides together to get the perimeter. So make sure when you're taking your test you read that carefully. The diagonal is 12 inches. So just like here on number 9, when I said they're talking about a square, you're going to use 45, 45, 90. Okay, so here they give us the diagonal is 12, and I need to find the sides. Remember, the sides of your square are all the same. So if we use hypotenuse equals leg times square root 2, the hypotenuse is 12. And if I divide by square root 2, I get 12 over square root 2. Now these are in decimal answers, so I'm going to put that in my calculator, and I believe on the test we did not do this, so I'm going to show you both ways here. So 12 divided by square root 2 is 8.49, we'll say. So 8.49, oops, sorry. So that's when I divide this, I got 8.49, which is one of the sides of the square. So in order to find perimeter, we would take that 8.49 and multiply it by 4, or you can add it 4 times. So I got 33.9, so it would be B. Now on the test though, I believe we took all decimals out and we just left them as radicals. So let's simplify this. We'd multiply by root 2 over root 2, which would give us 12 root 2 over 2. That reduces to 6 root 2. So that's one of the sides of the square. So if you're finding perimeter, you have to add that all together. So you could do 4 times 6 square root 2. You could add 4 of them together, but you would multiply these numbers and get 36 times the square root of 2. And if I put that in my calculator, 36 square root 2, I should get about the same, and I didn't. Why? All right, let me check that one. I know what I did. I did 4 times 6 is 36. That's not right. This should be a 24. So now if I check 24 square root 2, I get that same answer that we got. Okay, but I think on the test we did not do decimals, we did all radicals. So you would simplify the radical, there's one side of the square, and then multiply that by 4 in order to find the perimeter. Okay, number 11, geometric mean. So if you're just asking the geometric mean between two numbers, 5 over x equals x over 8. So when you cross multiply, x squared equals 40, square root. We want to simplify that, so we'll do a factor tree, 4 and 10, 2 and 2, 2 and 5. So I have one pair of 2's, and on the inside, these don't have pairs, so I'll multiply those together. So I get 2 square root 10. Number 12, find the geometric mean between 2 square root 2, so 2 square root 2 over x equals x over 5 square root 2. Cross multiply, x squared equals 2 square root 2 times 5 square root 2. So multiply these numbers together would be 10. Multiply the radicals together, since they're the same, it would be a 2. So x squared equals 20. Square root, x equals square root 20, and of course we will not leave it like that. So simplify, 2 times 2. So we have a pair of 2's, and the 5 is left on the inside. So 2 square root 5. Number 13, find x in triangle ABC. So here you're just trying to find the altitude. When you're trying to find the altitude, you can use your regular geometric mean. So we can do 4 over x equals x over 16. Okay, so you're trying to find the altitude and you're given these two parts. You set it up like geometric mean. So cross multiply, x squared equals 4 times 16 is 64. Square root, x equals 8. Okay, number 14. Now here you're given the altitude. So 20 is the altitude, but we can set it up the same way we did geometric mean on 13. X over 20 equals 20 over 40. So just like on 13, how the x's were in the same spot, here the 20s are in the same spot. So we'll cross multiply 40x, or bat and ball, whichever you're doing, equals 400. Divide by 40. So x equals 10. So we found that that's 10. Now it wants us to also find AC, which is over here. So you can use Pythagorean theorem because you know this is 20 and this is 10, and we want to find the hypotenuse. So let's just use Pythagorean theorem for that. So a squared, we'll say that's the 20, plus b squared, which is the 10, and we want to find AC. So 400 plus 100 equals c squared, which is 500. And let's see, 500 divided by 100. 100 times 5, and that's a perfect square. So 10 square root 5. Okay, so that's kind of a tricky one, so make sure that you look at that one carefully and you know how to solve number 14. Okay, number 15, find x. Now on one like this, you need to find the altitude first. Okay, so we need to find this piece right here. So let's just call this, we'll call it y. Okay, in order to find this, you do your geometric mean. So we do 3 over y, let's see, 3 over y equals y over 10. Okay, so you have to have this leg here before you can go find this x. So if we cross multiply, y squared equals 30. And nothing breaks down into 30. So this is square root of 30. Now I need to find x. So I would recommend Pythagorean theorem here. So if you're trying to find one of these sides of the triangle, just use Pythagorean theorem after you find the altitude. So we have a squared plus b squared equals c squared. So we'll say 3 squared plus square root 30. So this will be 9 plus, when you square a square root, you just get 30. So that would be square root 39, because it doesn't reduce. It's 3 times 13. Okay, so number 16 is the exact same way as 15. So the first thing we have to do, find this altitude. So we'll do geometric mean. 2 over y equals y over 12. So y squared equals 24. Square root, y equals square root 24. So 4 times 6. So we have a pair of 2's. So this middle part here is 2 square root 6. Then we'll use Pythagorean theorem to find the x. So multi-step process here. So in for a, I'll put 2 squared. In for b, I'll put 2 square root 6 squared equals c squared. So 2 squared is 4 plus. Now here I need to square the 2, which is a 4, and square that square root 6, which becomes just a 6. So now I have 4 plus 24, which is 28. Square root 4 times 7, 2 times 2. There's a pair of 2's there. So x is 2 square root 7. So what I would recommend doing for sure is on number 15 and number 16, practice those and then come back and check your answer. Make sure you know how to do those multi-steps. Number 17. Okay, so if this whole thing is x, okay, so if this whole thing is x and this part is 4, then that means this leg is x minus 4. So this one's kind of tricky here. So we're going to first use geometric means. We're going to do 4 over 6 equals 6 over x minus 4. Now when you cross multiply here, be careful. This is 36 equals 4 times x minus 4. So distribute. We'll add 16 over, which would be 52. Divide by 4. So that equals 13, and you have to be careful here. Let's see. Oh, that should be right. X equals 13, because we solve for x. That's kind of a tricky one. Okay, 18. Which set of measures could represent the sides of a right triangle? So the best thing to do is just check, does a squared plus b squared equal c squared? So you could just put that in your calculator. If I was checking a, I would do 9 squared plus 40 squared, and then I want to check, does that equal 41 squared? Well, that works. Okay, so if you wanted to check another one, like I'll check C, 7 squared plus 8 squared, and then I would check 15 squared, and that doesn't match, so that doesn't work. Okay, so you could check these other ones, but they won't work either. 19, Ryan has 3 sticks of lengths 6 inches, 10 inches, and 8 inches. He wants to join the 3 sticks to form a right triangular base for a model. Discuss whether these sticks form a right triangle. So again, this is just like number 18. Check it in here. So 6 squared plus, now I have to put the 8 here because the biggest one is 10. So I would do 6 squared plus 8 squared is 100, and 10 squared is also 100, so that works. So we could say yes, and you could say Pythagorean theorem works or something like that. But definitely make sure you show your work here and how you got that they work or not. Okay, number 20, find x. So here we have a rectangle. So we talked about if you have a square, it's 45, 45, 90. If you have an equilateral triangle, it's a 30, 60, 90. The rectangle is going to be the same. It's going to be a 30, 60, 90. So we have the long leg and the short leg, and I want to find the hypotenuse. So hypotenuse equals short times 2. So hypotenuse equals 20 times 2, which would be 40. So x equals 40. 21. A 30-foot ladder is leaning against the wall. The base of the ladder is 12 feet. About how high up the wall is the ladder? So we want to find this missing side. This is creating a right angle here. So let's just go ahead and use Pythagorean theorem, because we don't know if it's 45, 45, 90. We don't know if it's 30, 60, 90. So then we're going to go to Pythagorean theorem. So let's look for A. We'll put 12 in for B and 30 in for C. So we have A squared plus 144 equals 900. Subtract the 144, which is 756. These are decimal answers, so I'm just going to square root 756, and I got 27.5 in my calculator. Richmond is 200 kilometers due west of Tarrytown, and Hamilton is 150 directly south. So here's Tarrytown. So west, north, east, southwest. So Richard is here, 200. Hamilton is south. Find the shortest distance between the two. So this is just the hypotenuse. So let's use Pythagorean theorem. A squared plus b squared equals c squared. 200 squared plus 150 squared equals c squared. And I'm just going to put that in my calculator. I got 62,500 square root. And I got c equals 250. So 250 kilometers from each other. 23, find x. So we have, I believe this is a parallelogram, but if you're not sure, you could always just go to Pythagorean theorem. I believe you could use 30, 60, 90, but in this case, if I'm not sure, I'm going to go to Pythagorean theorem because it's a right triangle. So I'm trying to find one of the legs. So I have 11 squared plus b squared equals 28 squared. So I have 121 plus b squared equals 784. Subtract 121. Square root. So let's see if that has any perfect squares in it. I'm going to leave it as square root 663 for now. I'm not sure if that has any perfect squares in it, but we'll leave it like that for now. Okay, these last 5 are just your basic simplifying your square roots. So you could do factor tree. So I know this is 49 times 2. So I would write a pair and then do 7 square root 2. Number 25, you can add and subtract if the radicals are the same. So I would just do 8 minus 3 is 5 and leave the radical the same. 26, you have to simplify the square root 18 first. So 2 times 9, 3 times 3. So if I rewrite that, 5 square root 2 plus 3 square root 2, now I can add the numbers in front to be 8 square root 2. Okay, 27, you multiply and then simplify. So multiply the numbers on the outside is 8. Multiply the radicals, well, square root 5 times square root 5 is just 5. So I get 40. And the last one, multiply top and bottom by square root 3. So 7 square root 3 over 3, you can't reduce it, so that's your answer.